Alright, PBA pre-algebra class, we're looking at something for section 9.5 in our pre-algebra books. It's a little bit difficult just looking at it, but if you go through and slow down and look at what you're actually seeing, it's not that difficult. The distance formula, as it says here on this page right here, is actually a derivative of the Pythagorean theorem, which is a squared b plus b squared equals c squared. Problem is, you're taking points. You're taking an ordered pair and using them to figure out what it is, the distance between those two. It's almost like you're taking the two sides of a triangle and you're going to find the distance between those two. So in the book and also on the web page that you're looking at right here, this shows you the distance formula. It is the square root of the x prime 2 minus the first x. You'll find that answer and then square it. Then you'll add it to the second y minus the first y. Get that answer and then square it. So add them together and then find the square root, and that will tell you your distance. You say, that's not so easy. You're confusing me already. So let's look at these 2 points here. This is one of your checkpoints that will be in your lesson. So you'll be able to look at it here. We have two ordered pairs. As we went over, ordered pairs are telling us an x and a y coordinate. The first number is always the x. The second number is always the y. So we have two ordered pairs here. We have ordered pair number 1 and ordered pair number 2. So when we are filling out our distance formula, d equals, and we got this big long square root. Underneath it we have to fill in our second x, our 7, minus our first x, which is 11. We'll take that and we'll square it, and then we'll add it to our second y, which is negative 5, and we will subtract our first y from it, and then square your answer. So we have 7 minus 11. So we carry it down. 7 minus 11 is negative 4 squared plus, now we have negative 5 minus negative 2. As I keep saying, whenever you are subtracting a negative, you're technically adding it. So negative 5 plus 2. And that will give us negative 3 squared. Alright, so we got another step underneath it. Now what's negative 4 times negative 4? 16. Negative 3 times negative 3 is 9. 16 plus 9 is 25. And our square root of 25 is 5. So d is equal to 5. The distance between ordered pair number 1 and ordered pair number 2 is 5 units. Whatever that unit might be, it is 5. So we took our crazy looking formula. All you did was plug in the correct letters, correct terms, correct numbers for x, correct numbers for y, and you were able to fill it out, do our normal math. It does look a little bit different when you write them all out at one thing, but if you have to, you can break them down into the different compartments. But we took our second x, which was 7, and then we took our first x, subtracted that from our second x. Did the same thing for our y. So y2 minus y1, our second y, minus our first y, and worked it out. 7 minus 11 is negative 4. Negative 5 minus a negative 2 is a negative 3. Square both of those. 16 plus 9. You notice that we went from a negative 4 to a positive 16. Negative 4 times negative 4 going to give you a positive 16. Negative 3 times a negative 3 gives you a positive 9. 16 plus 9 is 25. The square root of 25 is 5, so our distance is 5. Alright, as we look at another problem just like this one, now we're using our distance formula. We're trying to find what is the distance between these 2 points. If they were on a graph, you could work them out. If you were given just points on a graph, you can plot them out and figure out what they were. We have 6 and 3 and 5 and 7. These are our 2 ordered pairs. So we're going to work it out using our distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we plug it in. We've got our big, long radical. Distance equals x2. That's 5. That's our second ordered pair. That's our x. 5 minus our first one, 6 squared, plus now y2, which is 7, minus y1, which is 3. And we're going to square that answer as well. So we got 5 minus 6, which gives us negative 1 squared, plus 7 minus 3 is 4 squared. Alright, so we're still working it down. What is negative 1 times negative 1? Well, that is a positive 1. What is 4 times 4, which is 16? So if we have 16, 1 plus 16 is 17. So our distance is the square root of 17. And we could try to factor. There's nothing there. 17 is a prime number, so we can leave it as it is. And so our distance is the square root of 17. And that is what we figured out. The hypotenuse of that, basically. By using a squared plus b squared, and a little different version of it. By using a different version of the Pythagorean theorem, we can figure out what our distance is. Alright, now we're going to look at the midpoint, which makes it a little bit easier than our distance formula. So with the distance formula, we're still looking at the 2 sets of ordered pairs. Still dealing with an x2 and an x1 and a y1 and a y2. But we're trying to figure out what is the middle point between these 2 points. 2 lines, 2 dots you have on your graph. What are they going to be? So our formulas, x2 plus x1, or vice versa, divided by 2. You're adding the x's together. So we take 3 plus negative 9 over 2. And we take 8 plus negative 4 over 2. Okay? So if we have 3 plus a negative 9, that is like a negative 9 plus 3. 3 plus negative 9. That is negative 6 over 2. Negative 6 over 2 is negative 3. So our x is negative 3. We have 8 plus a negative 4. 8 minus 4. That is 4 over 2 gives us 2. So our new ordered pair for our midpoint is negative 3, 2. Our x is negative 3, our y is 2. So our midpoint formula is this right here. We've got to figure out our x1 plus x2 divided by 2, our y1 plus y2 divided by 2. That gives you a new x and a new y. These are 2 formulas that you're going to have to memorize. By knowing those formulas, you'll be able to figure out how to do each of the midpoint and the distances for this lesson.